viewers, welcome to our technical channel Ganesh Piping. We are going to see today's session is on welding. Basically, ever since the evolution of this industry, there were methods for purpose of joining two dissimilar metals. Like for example, before the advent of welding, there used to be a riveting. So if you have seen the old boilers, especially the locomotive boilers, we can see that the entire body of the boiler is designed using rivets. But afterwards, when the technology progressed, the welding was invented, and it was a very revolutionary change that the welding has brought to the industry. So today we are going to see what and how this welding is important for the point of view of plant construction and plant design industry. So let's move forward and see. We will see how this welding is classified. Basically, before we start, I will give a short introduction about welding, what basic concepts, basic terminologies that are used for welding. On the right hand side, we can see here, this is a plate. Here, the picture shows that the welding takes place on this single plate. There is no two dissimilar plates. But in actual practice, we know that welding is used for joining the two dissimilar plates. Okay. So here we can see that the two dissimilar plates are termed as base metals, and we are using some external means which can be an electrode or wire, which we can see here, which is molten because of the high temperature of an arc, and that external metal which is deposited is called as a filler metal. So these two concepts we have to keep in mind, the base metal and the filler metal. So now moving forward, we will see that how this welding classification is being done. So first we can see here that there are two different wings. One is the fusion welding and the second one is the friction welding. Fusion welding, we are going to discuss more about the fusion welding because it is associated with the structural industry, structural piping, whatever is required for the plant design and construction. So for that we will focus on the fusion welding. However, friction welding is also very much important. It is also called as a pressure welding. So if we have seen the sheet metal or the automobile components, we have a lot of application of this friction welding. Basically, we are not going to go in much detail, but just to give an idea, friction welding is basically two different dissimilar components. They are brought together, and a high degree pressure is applied between the meeting parts, and there is a motion like rotation, so that there is, because of this pressure and the relative motion, they get, or because of some eddy current also, some current, these two parts which are hold together, they get welded. So that is the basically friction welding. We will move forward and see now the fusion welding. So in fusion welding, one is the gas welding, which we are going to exclude because for piping and structural we never go for gas welding as far as the plant design is concerned, plant engineering is concerned. So the preferred one is the arc welding. So within arc welding, we can see there are four different types. And the final one is a special welding, that is the chemical welding or laser welding, which we are not using for our case. So here we can see the MMA. Within arc welding, there are basically four types. MMA, which stands for manual metal arc welding, which is the most common welding that we see all around, with a stick kind of a rod and the holder, and then we go with the welding. So that is the MMA, manual metal arc welding. Then comes the TIG, tungsten inert gas welding, which is also called as argon welding. Uh, this welding is a kind of a special welding because it is basically applicable for thinner size of components. Like if we are trying to weld uh, pipes which are extremely thinner, like say 2 mm, 3 mm. So by MMA it is not possible, it is not feasible. So we go with this case with TIG, tungsten inert gas. It is also called as argon welding because there is a gas which is required to shield, to cover the molten metal, otherwise it will get oxidized and we cannot get a good quality weld. The third one is the CO2 welding, that is carbon dioxide welding, which is also called as MIG welding, that is metal inert gas welding, metallic inert gas welding. So what is that? We are going to see on the right side. We can see the uh, description about the image shows the MIG, MIG welding, and the final one is the SAW, that is the submerged arc welding. So this is basically a mass production welding. Of course, CO2 or MIG welding is also a mass production welding, where the speed of welding, rate of welding is higher. So submerged arc welding is done by means of machines, specially designed machines, and it is suitable for bigger diameter of pipes, maybe around 30 or 50 inches. So this, and they are basically higher thickness. So in higher thickness, the MMA if we are going to use, then it will consume lot of time, lot of efforts. To avoid that, we have some to and increase the productivity, we go with the submerged arc welding. So submerged arc welding, if we are going to start, then there is a condition that 30% MMA deposit should be there. Otherwise, we cannot start directly in the submerged arc welding. So how this takes place, that we are going to see in the coming slides. But before that, I don't have a video of this MIG unfortunately. So I will try to explain it by means of this sketch, this drawing. So this is a plate and this is the weld solidified metal. This is the filler wire. So this filler wire continuously supplied through some machine mechanism, continuously supplied by a rail. Okay, and there is a carbon dioxide gas which comes out from this nozzle, and an arc is strike, and when because of the temperature of the arc, this wire gets molten. So there is a arc length, arc gap which we have to maintain. So that when that arc gap is, if it is lesser than arc gap, the wire will stuck with the base metal, and if it is more than that gap, then there will be spatters. Spatters means it is a kind of improper welding, we can consider. So these spatters we are going to see in the next part of this video, second part. So before starting the actual videos of this welding, I insist you to subscribe our channel, like and comment, and share this video to the maximum possible audience. Okay, so now we are going to see how this functions when this metal is molten because of that temperature of the arc. We can see here that the gas will cover, carbon dioxide is a heavier gas, so that gas coat will cover, the blanket of gas will cover the molten metal, and it will avoid the oxidation of that molten metal. So that is why we can get a good quality welding. So now next we will move to the actual videos of the MMA, and we can see here how this MMA welding, most of you are familiar with the MMA welding. This is the electrode. This electrode is covered with a coat that we can see. So this is all about the video we can see here. So now we will go and see the TIG welding, tungsten inert gas. Like the MMA, there the arc was created by because of the gap which is struck between the base metal and the electrode itself, which is consumable. But here the electrode is non-consumable. It is a tungsten tip, and the filler metal is supplied separately by means of this wire, which we can see. So the purpose of this tungsten arc is to create an arc, constant stable arc, and in the temperature of that arc this filler metal is deposited. It's a very nice video we can see. At the end we can see a 360-degree view of the entire video. See how precisely the welder is going with this process. So this is a joint we can see here. So we are creating a joint between the two dissimilar plates. So now 360-degree we can see here. So the quality of weld is also very nice, and you can notice that it's a very thin sheet, which is not practical for welding using the MMA. So this is all about the TIG, tungsten inert gas welding. The motion of the hand is also very important. If there is a shaky motion, then we will not get a good quality weld. So this is important for all types of welding, MMA, TIG, and all except saw, because saw is not done manually; it is automated through a machine. So now moving forward, we will see. This is the submerged arc welding. So submerged arc welding, this is basically a tank or a pipe, big size pipe, which is placed on the special machine that is called as positioner. So now let's
It's high, no arc and little smoke and dust, etc.
see here. So this is a joint we can see, and the arc is strike beneath the layer of this flux. So we cannot see the arc, and this flux layer is protecting the molten metal from getting oxidized. So after it solidifies, this flux layer is removed, and we can see the deposited metal and the joint. So this is the joint basically, and here we can see that it is for the pipe. For heavy machinery also we can use this welding, no problem with that. See how it is done. But the condition, important condition is that you should require a 30% MMA deposition before you start the submerged arc welding, SAW, saw welding. So there is a flux hopper. So the flux hopper will create this. See here, it is completely molten inside. So the flux hopper will create will allow the flux to come out, and it is in some granular form, like like a soil particles. See how the welding takes place. That's the molten slag. Okay. So the speed of this weld is adjusted by the speed of the machine, which is called as positioner or tank rotator. You can Google, by the way, what is tank rotator and positioner. You will get several videos on how this positioner works. Okay, and the speed of the filler metal, that is the speed of the wire, is controlled by the machine, the welding machine. So we can see here there are two nozzles. One is the welding nozzle, and the surrounding that we have a hopper or the conical mouth from where these flux granules come out. So this is the best example of productive welding process, submerged arc welding. Now here we can see one important concept of welding, that is called as the polarity of welding. Welding can be used both for uh, connecting the metal and welding can be used both for joining and cutting the metals. So for that we have to understand the concept of polarity. Here we can see that this is a negative electrode, this is a negative pole, and this is the positive pole of the welding machine. Please remember that welding requires a DC current. So best quality welding is basically done by a DC machine. So in that we have to control the current because for smaller gauge electrodes you require lesser current. For higher gauge electrodes you require more current for melting the filler metal. So here we can see the diagram. This is basically the parent metal, and this is the filler metal. The electrode, this is the metallic electrode. It is covered by means of the flux. Okay, so during the melting process, the filler metal, this core wire, gets melted, and the flux will provide a solidified slag cover to blanket the molten metal so that there is no oxidation, and because of that we get a good quality welding. So basically we have to understand that what is polarity. Normally, in case of welding, there are two different methods. One is called as welding, which is used for joining the metal, and the other one is called as gouging, which is used for separating the two dissimilar metal. Like for example, if we have welded two plates, and because of some reason we have to separate these two plates by removing that welded joint. So that process we can use by gas cutting, but in case of stainless steel we cannot go for gas cutting. So in that case we can use the gouging. Of course, for carbon steel plates also we can use gouging if we don't have the gas welding facility, gas cutting facility. Sorry. Now what happens during the joining of the metal, that is the welding process, you have to connect the holder, and this is the earthing. The earthing should be connected to the negative pole, and the holder should be connected to the positive pole of the machine. In this case you will get a welding, that is the joining effect. So in that case your 85 to 90% of the metal will be deposited from the filler metal, and the 15 to 10% fusion will take place on the parent metal. That is the two dissimilar plates will also fuse by 10 to 15%. So that is why we will get a homogenized joint and it will be strong enough. However, if we reverse the polarity, that means now the holder is connected to the negative pole, and the body, that is the two dissimilar metals now which are already welded, now I want to remove the welding, so they will be connected to the positive pole. So whenever there is a positive pole, we can understand from this that maximum number of fusion will take place on that side. Okay, so as soon as the arc is striked, the welding, the gouging effect will take place, and the electrode which is connected to the negative pole, it will start removing the weld. These electrodes basically are carbon electrodes, and they are used for gouging process. So this is most common when we don't have the gas cutting facility. So this is all about the part 1 of this welding session. So keep watching this second part also for the welding session. Till then, we will have a break, and also let us know your feedbacks on this video, because we also learned so many things from you who may be more expert on this topic, and you can share your valuable information. We also have our Telegram channel. Link for joining that Telegram channel is mentioned in the description of this video. So stay connected with us, and thank you for watching this video. Good day.